Hi children, now we discuss about the fifth case of a concave mirror, and here a ray diagram is ready with some of the important points. I'll tell you what are the points already marked in the particular ray diagram. And here we have the same concave mirror having the aperture mm dash. P is the pole of the mirror, F is the principal focus of the mirror, and C is the center of curvature of this particular mirror. And in this case, we are going to place an object exactly at the principal focus itself, exactly at the point F. And we studied that if you place an object at infinity, we will get an image exactly at the principal focus. But here we are going to keep the object at F, and we are going to find what will be the position of the image formed, what will be the size, and what will be the nature of the image formed in this case. Okay. So the setup is ready, or the ray diagram is ready, concave mirror is ready, all the important points are already marked in the ray diagram. Now I am going to keep an object exactly at the principal focus of the mirror. This is our object AB placed on the principal axis and exactly at the point F of the mirror. And here same way we are going to consider two incident rays. One is parallel to the principal axis and other one is passing through the C of the mirror or center of curvature of the mirror. So same way we are drawing an incident ray that is parallel. This is the direction that strikes the mirror at a point O, and it passes through the principal focus after reflection. This is according to the first rule. ON is the reflected ray. First incident ray AO, the reflected ray ON passes through the principal focus according to rule number 1. And secondly, I am considering the ray passes through the center of curvature of the mirror. So this is a ray passes through the center of curvature of the mirror. So this is the direction of the incident ray, and O dash is the incident ray. So according to rule number 3, that ray traces back along the same path in opposite direction. So this is the reflected ray. And reflected ray passes along the same direction but in opposite, same path but in opposite direction. O dash N dash is the reflected ray. And these two rays are parallel in nature. They are not going to converge, or they are not going to coincide, or they are not going to intersect at a point. These two reflected rays are, this is the first reflected ray, this is the second reflected ray. See, these two rays are parallel in nature, or reflected rays are parallel, or they are not going to meet, but they will meet at a point called or a far off distance called infinity. So here they are not going to meet at a point close to this mirror or close beyond C, but definitely these parallel rays will meet at a far off distance called infinity, or at infinity we will get a enlarged image of the object. So we are not going to get a just enlarged one, highly enlarged one at infinity. So that is the result, or that is the type of the image formed in this case. Okay, so here we cannot draw an object image here, because we are concluding that definitely these two rays, parallel rays, will meet at a far off distance called infinity. So here at infinity we will get a very highly enlarged image, or a very larger than the object. AB will be formed at F at infinity. It will be a very large image of the object, and that is real, and really they are going to meet at infinity. So real image. So real images are always inverted, and we are going to get inverted image, and size will be highly enlarged one, or very much larger than the object. Okay, let me write the details about this image: position, size and nature, and position at infinity, and size highly enlarged, and nature real and inverted. These are the specialities of image formed by a concave mirror if we are placing an object at F. So at F, if we place an object at F, we will definitely get an image at a far off distance called infinity. That will be highly enlarged image, and here this will be the case where we are getting a highly enlarged one, or highly enlarged image. And in opposite manner, if you are placing an object at infinity, we are going to get a very point sized image. That is just the reverse of the first case. Okay, so this is the position is at F, and the size is highly enlarged and the nature of the image is real and inverted in this case. So this is the ray diagram which is enough to explain the details about the image formation. Though we are not marked the image, but we are concluding that the image will definitely meet at a point called infinity. So at infinity we will get a real and inverted and highly enlarged image of this object. So with this we completed case number 5. Okay, thank you.